Hello, 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 hello. Mic check 1 2. All right, so let's get started. I hope you guys can hear me now. I hope you are hearing me. Can you guys hear me? If you can, please type a 1 in the chat. I will really appreciate. I hope you guys can hear me now. I hope you are hearing me. Can you guys hear me? If you can, please type a 1 in the chat. I will really appreciate. I hope you guys can hear me now. I hope you are hearing me. Can you guys hear me? If you can, please type a 1 in the chat. I will really appreciate. Okay, so yeah. All right, so let's get started. Let's get started. Let's get started. I actually have an app called Bombastic, which is a little bit weird. But let me close this folder and restart from scratch. So guys, I hope you've been taking good care of yourselves. All right, so let's get started. I'll pause this test right here and then we shall begin the discussion. Let me first see how I can get the chat. All right, so yeah, let's get started. Let's check something here. I'll keep my chat right here, and then I'll have the side for the coding. All right, so yeah. Hi guys, I hope you're doing great and are taking good care of yourselves. Welcome to this live stream. In this one, I would like to discuss Docker Compose, and we're going to be looking at very simple examples of how we can use Docker Compose to help us run multiple container applications. So in the last live stream, I talked about containerization and we looked at some of the basic concepts that are involved when using Docker. Now, I did not cover that much. Of course, there was so much to cover that I could not talk about in that one live stream. So I'm going to be talking about Docker Compose, and then we'll use this live stream to discuss more about Docker, and we shall look at how we can run apps that have many components to them. So just like you guys know, real world applications have a lot of components to them. And the reason as to why Docker exists is to allow us to run these applications so that we can easily build them, easily share them, and easily run them in multiple environments. Now, the example I showed in the last video was one of a very simple basic application, and that introduced us to things such as writing a Dockerfile, which you can think of as just a file or a script that allows us to lay down the steps that are going to allow us to create a container image. Now, a container image is basically, you can think of it as a prototype for which a container or from which a container is built. Now, if you have sort of like an application, that application is one that has things like its runtime, its environment, and its configurations. So you can use a Dockerfile to lay down all the steps that you use to configure your application. And then when you are done creating your Dockerfile, we'll use Docker to build an image from that Dockerfile. Once that image is created, you then run a container, which is a process on your computer that runs within Docker. So that process has basically a machine, or you can think of it as a machine of its own or a computer of its own. And through that, you can manage it as if it was a container. We looked with a computer in that case. So we looked at very many things such as how we could run containers, how we would manage containers, view logs on containers. We could inspect containers. We also looked at how we can use images from container registries such as Dockerhub as though we had them installed on our computers. So in this one, my aim is to talk about Docker Compose. Now, I'm going to be using very simple examples, but for each of those examples, you'll be learning something. And my hope is that you guys will learn something from this video. So let's get started. Now, I have some stuff that I've put right here, sort of like notes to guide me into what I'm going to be talking about today. It's just a summary of the things that I plan to at least tackle and explain when discussing Docker Compose. So the first is going to be the introduction, where we shall talk about what Docker Compose is, and then we shall move to the question, why use Docker Compose? Then we shall move to the key concepts section, where we shall be talking about the Docker Compose YAML file and how to create one. Then we shall dig into things such as services, which are basically containers that you may want to run together. We shall talk about Docker and networks, and we shall talk about that interesting stuff. Then volumes, which you can think of as just persistent storages on your containers, file systems that allow you to persist things in case you want to have these things that you do not want to erase each time you create your container, stuff like that. Then we run some examples. I want to basically show from the simplest example of a Docker, of a multi-container Docker setup, to one that has maybe a database or Redis and so many other components. And we shall conclude this live stream. I don't think it will be that long. If you want to learn more about Docker, I created a live stream last week, which was one that contained the concepts that will enable you to learn how to use Docker at a very basic level. So to start, let us start by introducing Docker Compose. What is Docker Compose? Now, Docker Compose is one of the tools that Docker as a platform gives you. And what it does is to help you run and define multiple container applications. Now, just like I said, I had some boxes for demonstrations. Those boxes were allowing me to basically show you how you can have your app contained within a container. That app can have its own sort of like box in which it runs, but then you realize that you need some other things onto that app. For example, a database. You may have things like Redis. You may want things like Nginx. You may want things like any other thing that is external to your application can run within a container of its own, and then that container can be made to run with your application. And the beauty about Docker is that once you have a tool such as Docker Compose, you can then sort of run these applications the same way. And this is why Docker Compose is important. It's important because it helps you to run your application in the same way you'd run it in a production-like environment. And we're going to be looking at how it helps us do that. So the introduction, Docker Compose is simply a tool for running multiple container setups. And by multi-container setups, we basically mean applications that sort of have many components, some of which include the app, which may be the code, the configurations of the code and all that stuff, and then external components that the code may need to run. So you may think of databases and other systems that you may want to register onto your app. Now, Docker Compose does not only allow us to bring in external components, we can even get creative in a way that we can build applications as services. Now you can think of your monolithic app, one that contains its own database and all the logic that communicates to that database and all the components being in one large box as a monolithic application. We can break that down into very small chunks or very small services. And those services can also be run inside their own containers with their own databases, with their own settings. And we can still register them or make them work with our application through Docker Compose as services that our application depends on. I'll be discussing that in detail. I think I'll create a video about it. But for now, that is the simplest example I can give you. So why use Docker Compose? Now, Docker Compose basically allows you to achieve simply 4 things. Number one is simplicity. When we want to run a container, just like any container we may have from the images we have, so I have a lot of container images inside my Docker desktop environment right here. And we may want to run containers that do different things from these images. Now, a command to run a simple container like the one I have here, I created this for a simple example while I was researching this video. Maybe something like, let me just type it in here. So I hope I have opened that out. I actually do not have it. But a command to run that container may be something like, let me clear this. Maybe something like docker run, and then the name of the container, which in this case is simple. So we may want to run it from the image, which is this simple Flask API version 2. So I may copy that or call it simple Flask API version 2. And then you may want to provide other options like the port. So this runs on port 5000. So you may want to map Docker's port 5000 to the port 5000 of our machine. And then you may want to give this a name. And let's say this name is going to be app. And then you may think of any other arguments that we may need here. In such a scenario, this command is one that we're going to need to run this single container. But what if we needed to run Postgres? If we needed to run Postgres, we would open up another terminal and then basically do the same thing. We may run something like docker run and then let's say Postgres latest, which is the name of the Postgres image I have currently. Then we would specify other like options, like let's say run, the name is maybe going to be database. And then you may want to specify other options. And this basically leads to a confusion where you have multiple commands, each of them having all these options and each of them having very many things that you can specify within those commands. Now, Docker Compose makes this setup easy in that if you have an application such as the one we have here, you're going to run it and still run it with any other components that it works with just one command. And all that is done through a file called the dockercompose.yaml file. So dockercompose.yaml file is a simple file that enables us to basically describe our multi-container application and how we can set it up and how we can run it. We can even specify things like which app depends on another app or which service depends on another service and so on. Now that basically is the simplicity that Docker Compose allows us to have. Now, when you talk about consistency, remember when I was introducing Docker in the last live stream, I talked about how Docker solves the it works on my computer problem. The it works on my computer problem is one in which you have your application running well in your environment, but then you cannot make it work the same way in another environment. So Docker allows us to basically run an application in the same way for as long as I have Docker installed and the other person has Docker installed. I can share with them the container image of the source code that I've written, and they'll be in position to run the app the same way if I've created the image right. So that consistency in the way we run our application is supercharged when we use something like Docker Compose, because this time if I have my Postgres in a certain way, that progress will still work the same way when someone gets our containerized application that uses our Docker Compose. Now for portability, we can think of it as if let's say we had our application and that application had all these components, at the moment someone has each of the components set up within Docker Compose, they can then share that same arrangement or that same setup with another developer who has the same setup. And both of them will be in position to still run Docker or run their application the same way. Now, the interesting thing about that is that this kind of setup, the one that you use when you're using something like Docker Compose, can be a very good one. That's why I find that this is highly used when creating things like not desktop environments, like development environments. So development environments, things like that can be set up locally, and you'll have the application running the same way it runs in production. Another thing we may think about is integration tests. Now, when you're carrying out integration tests, you want to check if your app integrates well with any other components it may have. For example, if your application uses something like Celery, then you may want to test how it interacts with Celery, or how it basically schedules tasks or runs tasks in the background using Celery. So to do that, you may need a setup that has other external dependencies or other external components, like let's say Redis and or RabbitMQ. So such components are going to be very easy to set up within a Docker compose.yaml file. Let's talk of scalability. Now, what is scalability? Scalability simply refers to the ability for your application to adapt to load or to adapt to increase in constants, such as how many users are using it. So let's say our app is having 100 visitors every day. What will happen if our app then gets to points where it's getting 1 million requests per second? So it's very easy for us to manage computer resources inside that Docker compose.yaml file. And those are things I'll make videos. This one is more of like an introductory video to Docker Compose. So you can be able to edit things such as the amount of instances the service is going to have within your application setup. And then you can also adjust the amount of resources you're giving to a service, all inside your Docker compose.yaml file. So the key components or the key concepts that we need to look at today are basically going to be the following. We're going to have Docker compose.yaml. It's basically a file like a Dockerfile, a special file that allows us to define multi-container applications. Then we shall look at services. You can think of services as each of the containers we want to be within our entire setup. So if you have our application and its configurations and its Dockerfile and all that stuff, that is a service of its own. If you have a database, that database has all its configuration and all that stuff, then that is a service of its own. If you have an application like, let's say, your authentication service that is going to be serving the main application, then that can also be considered as a service of its own, and so on. Then networks. Networks basically allow Docker to manage how containers talk to each other. So if you have your application container and then you have your database container, configuration and all that those are going to talk to each other in a way that Docker is going to manage. So it does that in networking. I don't know if I'm speaking the right English right now, but the idea is that when you have all these multiple containers, they work within a network, and the way Docker knows how these are to communicate to each other is through Docker networks. And I'll try basically going in depth about how that works. We've actually looked at some of the basics of that when we are dealing with a single container setup in the previous live stream. where we did things like mapping the port of the application in Docker with that of the host machine. And I'm going to be talking about that in much more depth. Then we shall also look at volumes. Volumes can be thought of as persistent data storages on the containers file system. So if you have a database, this database is going to be storing persistent data. And the way you want to make Docker deal with that is through the use of volumes. Now think of a volume as a folder on the containers file system that Docker will look at and not delete each time you, let's say, start your container or stop your container. So those are what volumes are. Now, I think I've talked a lot about this, and let us get into the actual practical stuff. Now, I'll start with a very simple example. What if you had two scripts in different programming languages that all depended on each other or all ran together with each other? What would you do in that case? Of course, the first thing would be for you to think of a way in which you would execute these scripts at the same time. And by executing these scripts at the same time, that means you would maybe run the corresponding commands for each of the services or the scripts, and then you'll have them run at the same time. Now, this can also be the same thing we can apply to containers. You can run one container and then run the other container that container depends on, and you'll have these containers run at the same time. Let's start with a very simple example. I'm going to go to the Docker hub or the Docker container registry, and I'll search for Node or the latest image of Node. What is happening? It's not Docker hub. Let me go to Docker hub. Let me just search it here. So if I go to Docker hub, I want to go ahead and get the image of Node or the latest image of Node. So I'll go here and search Node. So that should take us to the Node.js image. And what I'm interested in is getting a tag. So I think I'll work with Node.js. Let me just get Node.js latest. So let me just try to create a new VS Code window here. And then I will open up a folder anywhere. So let me just create that in my documents. So I already even had that example, but let me just create it for you guys to see. If I had a Python JS kind of setup, I want to run two scripts or run two services, each being executed in a script of its own. So let us do something of that sort. Now, I want to go ahead and create a new file in Python. So I may create this as, let's say, let's just say main.py. So main.py is a simple file, and it's going to be doing a very simple task. So let's say main.py is going to print something or basically loop over a list and do something for a given amount of times. And then script B, which will be in JavaScript, will also be doing something of that sort. Now, what I'll do is to do something like import time, and then we may want to basically also import, or let me just actually just use date time. So I can say from date time, import date time, and then using the datetime class, I can also import sleep. I mean, I think I need to import time. I'm experiencing a little bit of a lag. I don't know how many things I have open here. So let me just try to close some stuff. Maybe I'll open this later. Let me just close it. So going back here, I'll say import time. This is a very simple script and it doesn't really do that much, but I want to run it together with my normal like, let's say, JavaScript file. So I'll say something like, for, let's say, I in range, let's just say for I in range 20, then I want to just go ahead and print the time. So I'll maybe do something like print. I'll use an F string to say time, and then I'll print the time. So let me just do date time, date time dot, what should I do? Let me just say date time dot now. Now I'll just use a date time without time zone information. And then, yeah, let's just do something like that. If I execute this script, why is this taking time to load? So I said Python or Python 3 main.py, that will go ahead and just print the current time or time. To make this interesting, I'll make this pause for some seconds. So let's say each time the time is printed, we shall just go ahead and make the time pause for about 2 seconds. So I'll go ahead and run the script again, and then you'll see a delay of 2 seconds, and then the print will be made. So that's our first example. Now, want to be in position to do something like that in JavaScript. So let me go ahead. I don't know if I even have Node installed. I will just create a new file right here. I'll just call this, let me just call it index.js. Or to just be on the safer side, let me just create an index.html. So inside this index.html, I want to create a file called index.js so that this is executed from the client, because I do not have any sort of like, node installed here. So I'll just create an h1 and then create a script that points to that specific JS file. So in this case, I'll say index.js. Now, once I'm done with that, I will go ahead and just simply do something here. So what should I do? Let's just try and console.log a new date. So let's say new date dot get day, get full, let's say get time. So if I did something like this, let me try to open this up with live server and then see how that will go. So we have our index.html, and then when I go to the console, this is printing time. So yeah, it's printing the time, but it's printing it in a very weird way. I don't know how to read or get dates as times as date time objects in JavaScript. But let's say we had these two sort of like apps, or basically simple scripts that train together, one in a different programming language than the other. I don't know if my English is right, but these are basically two scripts, one running in one programming language, another one running in another programming language. And for this example, I just do not want to make it complex. So let's say this is the JS script and this is the Python script, and each of these scripts are supposed to run together at the same time. The first thing we'll do is to maybe containerize them. So let us do exactly that. So what I can do is to come right here, create a Dockerfile. So I can say, I can have my first Dockerfile. So this is going to be like the Dockerfile for our Python app. So I can even say this is for the Python app. So we can do the normal from the base image, which is Python, and then 3.13 -slim, and then we can create our workda, and then I can basically go ahead and run the command So I have to first copy the scripts, maybe move main.py to the containers app directory, the one that we've created right here. And then finally, I will go ahead and execute the command to run this. So I'll just say something like Python 3, and then I'll point to main.py. So this is a very simple Docker file. It has very simple commands to just set up a very simple image for this script right here. So you can build an image from anything as long as you know the steps to set it up. So this is a very simple Python script, and this is its Docker file. So let's go ahead and test that. I'll go ahead and build its image with Docker build -t. And in this case, let's just call it let's just say simple py script, maybe version 1 as the tag, and then you point to the Docker file as dot. So if we do that, then our image will be created. And once this image is created, now what I'll do is to go ahead and run a container. So to do that, I'll say docker run, and in this case I have to know the image. So let me go back to our images section right here, and the simple script we created is going to be, now I have a lot of things here. So the last one is the simple py script, which is this. To run it as a container, I will point to it, and when I run that, of course it's supposed to just execute, it's just supposed to run from the image, and we'll have our container running. So let me just try to see what's happening here. We go to our containers right here. Maybe we go to this, which is built from our image. We actually do not have any logs, so I wonder what's happening there. But we of course know that this is running together with our, which is actually running here. So I'm actually getting some logs here. So our logs have been executed. Now, let us go ahead and do the same thing for our JS app. So the thing is, you can point Docker to a Docker file, and I'm going to be showing you that. So we are having one Docker file, but we are also going to have another Docker file. So let's say we have Dockerfile 2. So Dockerfile 2 is still going to be, we want to run the simple JavaScript script. So for our case, I'll say from this time we are building from node, which is the name of the image, and latest is the tag we want to use. Then we want to set as work directory as /app. So let me go ahead and delete some of the some of the things that are making this be a little bit confusing. So I'm going to delete this py.js app. I'm going to delete this py script thing, and then I'll delete py.js py script. I'll delete all of those so that we remain with the only images we shall be using. So once I've deleted that, I now have simple py script, which is the only Python image we've created from the simple Python script we wrote. So in the containers, I will also delete some of these. So I'm going to delete these Flask containers. And now we have only the one that we've created from the py script. So now let's go ahead and create our workda. So our workda is /app, and then we can move that to, it's actually copy. We can copy the index.js file to our workda, and then we can finally run it with node. And then shall point to index.js. Now this is the simplest example I can show you of two applications that are containerized. Each of them is going to run with another application. So when you have such applications, Docker Compose is what will allow you to be in position to run both of them at the same time. But before we use Docker Compose, let's go ahead and also build the next container. So we can do that with Docker build and then -t. In this case, we want to point to that file. So Docker can also allow you to point to one single file through the, so let's first actually specify the file. So I can do -f and then I point to the Docker file I want to use, which is Dockerfile 2, and then I can give it a name and a tag. So in this case, I can say simple JS script. Then I will point to where that I've actually gone ahead and said that I want Dockerfile 2 to be used as a Docker file, but that Docker file is still going to be found in the current folder. So if I say enter, that will go ahead and then build the image from that simple script that we've written, the simple JS script. So when I go to the chat right here, I have some questions here. Hey dude, hi Aldrich, hi Team Droid. Is it case sensitive or is it like SQL? Well, I'm not really sure if it's case sensitive. I think you can write the same commands with lowercase, but then I think it has a problem with how you write the commands. I think when you keep it like uppercase, it will be uppercase. So I'm not sure. I'll try to maybe ask, is Docker syntax case sensitive? So it's not case sensitive actually. You can write your commands in both uppercase and lowercase and you'll still be good to go for as long as you're using the commands that Docker is basically the commands that Docker is familiar with, like the from, the work does, the copies, the commands, the environments, the args, and all that stuff. You can read more about that in the Docker documentation. So I think it's not like a must for you to use the uppercase syntax. You can use the lowercase syntax for as long as you have the commands. I think it's just not okay with mixing the two. So I'm still waiting for this image to build, the one I'm building for the small app we are going to use. And then we shall proceed. Kindly feel free to tell me where you're from and if you want to learn something related to the topic we are discussing. If I know it, I'll basically cover it here. If I do not, then I'll try to maybe make my research about it so that I make a separate video from it. Oh, this is taking quite a lot of time. Let me actually just see if I have an image of Node here. So if I go to images, I am going to go, I actually have Node here. So let me just copy this instead of wasting your time. I am dealing with Ugandan internet, guys, so please forgive me. Ugandan internet is not the fastest. So I will paste this right here. So this is going to be Node 24.1 Slim, which I already have. And then I'll just go to my terminal right here, run the same command. I'm sure this time that command will run faster, given that we are, let me try to stop this terminal and then try to run it again. I'm sure this time it will run faster given that I am using an image that's existing, so it won't have to fetch it So I'll just call this simple JS script, and then I'll point to, actually this is supposed to be the tag, which is this. And then I want to also provide the file which I want to use as my Docker file. So that's going to be Dockerfile 2. So I want to point where the Docker file is, which is in our current folder. That's where I am providing dot. So basically this helps you to provide the relative location of your Docker file. So if that Docker file is found here, you'll say dot, and if it's found in another folder, then you'll have to use the relative location of that Docker file relative to where you are. So it seems like I have a mistake here. So let me see Docker run. I'm actually using Docker run, which is supposed to be Docker build. Sorry for that. So I'll say Docker build, and then that will go ahead and build our image. So I think this time it's going to be a little bit faster since I'm using an image that's existing. Oh, hi Aldrich. Thanks for watching from New York. That's really far. I'm really glad that you're watching this live stream. So let's run that app. So if I say Docker run and then simple JS script, in this case, it will go ahead and run our JS script and then it will stop. So that's how Docker works. It will run our code. Now for web servers, it's going to be a little bit different given that web servers are like infinite while loops. They'll run until maybe something stops them from running. But for our simple scripts, we basically have that execution, and then the container will stop the moment the script is done running. So let us now look at Docker Compose. How does Docker Compose help us to run these applications? So since we have both of these containerized applications, we can simply create a file called a dockercompose.yaml file to help us be in position to run them as though they were one app. So how Docker Compose allows us to do that is by helping us define services. So services are going to be any sort of like container you may want to run within your entire application setup. So you can think of YAML as a file format that is close to JSON. I think it's even like a subset of JSON, if I'm not mistaken. But it also has that kind of like key value, and then you'll have lists, and then you'll have like mappings and so on. So let us start by looking at how we write things in Docker Compose YAML. So you're always going to define things like services. So services are always going to be the first things you define within a Docker Compose YAML file. So services are going to be like an object or a JSON object, and you're of course going to write the key, which is services, and then you'll define your values or whatever is contained within that object as other keys or other values. Now in this case, we are going to start with the services. So services, just like I explained, are containers that you wish to run within your multi-container setup. So in this case, you're going to have the first service being our, let's just say this is going to be the Pi service, or you can think of it as the Pi container. And then you're going to have the next one being the JS container or the JS service. So just by doing this, we have been in position to tell Docker that these are the two containers we want to run with each other. Now, by doing this, we then have to give Docker more details about how those two containers are going to run. We can do this by specifying the images that they are going to run for or to run from. So in this case, we can start by basically pointing to the images themselves. For example, if I were to go to Docker desktop right here, I have simple Pi script, and I also have simple JS script being two images. Now I can copy their names like this. I can maybe say simple Pi script. So let me go right here. I can just say image, and then image is going to be simple Pi script. If that image has a tag, then I have to point to that tag. So in my case, that's v1. Then I can do the same thing for our JS script. I can point to the image and say that in our case, we are going to point to the JS script. So I can say simple JS script, and then I point to the latest. So that's the name of the image. So in the previous video, I talked about how Docker works. It works in the way that it will search for the image if it does not exist in its image cache. It will then download it. So basically the steps are when you try to build or run, actually when you try to run a container from an image, let's say PostgreSQL, Docker will first of all look for PostgreSQL or that specific version of PostgreSQL in, it will look for that specific version of PostgreSQL on your machine. And if that's not available within your images, it will then download it from a container registry like Dockerhub. Now for our example, whenever we say image, we point to the name of that image. Now this can be Redis or this can be Postgres or any other thing that's external. But for our cases, we have all these images present. We can simply write their names here and we'll be in position to run our services. Now these are just two scripts, a JS script and a Python script. And the beauty about Docker Compose is that instead of us having to memorize the commands that are necessary to run these services, we can then just choose one single command to run these services. So to do that, we can come right here. So if you have Docker installed, you are always going to have Docker Compose installed. So to access the Docker Compose CLI or the command, you'll just go ahead and type something like Docker Compose --help, and that will help you access all the commands that you are going to be using when dealing with Docker. So actually when you're dealing with Docker Compose. Now the command that you need to spawn or to run all these containers is the Docker Compose app command. So when you define all of the services that you want within your multi-container setup, you then need Docker Compose app to start them or to create them if they are not yet existing. Now, given the fact that we are pointing to images, we then need to run containers out of those images, and running Docker Compose app will help us do exactly that. It will create containers from our images and then run those containers. So let's go ahead and do that. I'll pull up the terminal right here and I say Docker Compose app. So meanwhile, I'll be reading through the comments. So pull access denied for that repository does not exist, or it may require Docker login. So what may have been the problem? What do you think is the problem? Your Pi service is going to use the JavaScript image. Oh, sorry, may have done a mistake. So I'm seeing Pi image, simple Pi script version 1. Oh, let me maybe confirm with Docker desktop. Simple Pi script version 1, simple JS script Python. What may be the problem here? Am I writing the wrong syntax? Am I doing something wrong? How am I defining the services? Now, I may need to refer to the documentation. Now this is... Yeah, I think it wasn't a mistake. I'm just saying that it's failing to pull the images. It's saying something to do with pull access denied for this because this does not exist. Now I'm wondering why that is happening, given that I have that and I've specified the right. Let me see. This is the name of the image and this is the name of the tag, and it's saying like I am not having that, or it has failed to pull that. So image this, image that. Guys, can you bail me out? Yeah, so that's the thing about live demos. Um, anyway, let's try to figure this out together. Um, that's the right syntax. You define the services, and then you come to the name of the service. So we've called this pi, and then we've called this JS. So simple pi script version 1, and then simple JS script latest. I'm wondering why this is failing to run, honestly, because I've built the images locally. Are the images running? Let me see. I think I have containers that are actually using those images. Let me just try to maybe delete these. So they are not being used, I think. Yeah. So let me try running. But I don't think that's the problem. Oh, that was actually the mistake, by the way. That was the mistake. So the images had to be, for some reason, stopped. And then I had to go ahead and stop the containers that were using the images for this to work. So for now, we now see what happens here, that Docker Compose will create a network in which all these will run. So we see the first container, the JS container running. It was created. It was actually, first of all, created from the image we built, and then it was run. So basically, they create a network, and after creating the network, they create the containers, and after creating the containers, we now get to see the containers run, and we get to see the steps that the containers take to run. And the images running, I think that was the problem. The images were running. I was having containers that were running. So I had to first of all stop them. And when I ran Docker Compose, basically it went ahead and executed and created the network, created the containers, and finally ran the code, ran the containers. So as a test, you can try to run the Nginx latest image. Yeah, I can, but then I think that will have to fetch it. And just like I said, I am dealing with Ugandan internet. I don't know how big that is. So yeah, but I hope you guys can get at least what I was trying to explain. What we've so far done is to describe or define two services. The first one is the Pi service. This is the name of the service, and this name is going to be useful in that when we are trying to deal with a container or the service, we shall use the name that we've defined as the name of that service instead of its, let's say, container ID. And then we've specified the image from which this is built. So that's going to be the simple Pi script version 1, which we've already built from the example I showed. Same thing for the JS image. So we now have these two scripts running together inside this simple setup. And I also saw someone say something like a real world example. Of course, that's the same thing that I'm going to be uh, talking about. I'm going to be showing you how we can have a setup that has maybe a FastAPI app and then a Postgres database, and then something like that. But then this was a very simple example to introduce you to services and how you can run two services. Now, another thing that I may want to show you from this is that instead of pointing to the images that you've built, you can point to Docker files that you have, so that you then allow Docker to build images from those Docker files and run containers. How you do it is by using, you'd come and do something like build, and then you'd specify something like the context. So the context is where the Docker file is going to be located. And then you would also point to the Docker file you want to use. So in this case, the Docker file is going to be the name of the Docker file. So if you had Dockerfile, that would be the Docker file. And then for the second case, you may use something like build and then context. So context is going to be dot. That means you want to build that. You want to build that image from the current directory you're in, and then you want to point to Dockerfile 2 as the Dockerfile from which that image is going to be built. So that still will work the same way. If you go ahead and run Docker Compose app, you expect it to then go ahead and behave in that same way. You could run them in their own containers, then use Docker Compose with a single YAML file to manage it as a multi-container app. Thank you for that. I think that's exactly what we have done for the first example. We went ahead and built them as their own images, and then we ran them as containers in our basic Docker file. In our basic Docker compose.yaml. So if I run Docker Compose app, it will still behave the same way. So I don't know why this had to happen, but anyway, it will take all the steps, build from the Docker files we've specified right here, and then we'll then see our containers run. So yeah, that was just a very simple example. So that's how you can build your images and run containers from two Docker files using Docker Compose. Now, let's do something a little bit more interesting, something that doesn't have to do with simple scripts. But then anything can be a container, anything can run in a container. From your script, you can have a script that does something interesting. You can containerize it and then have all these other components to it running together with it inside a container. So that's just basically what you need to know about services. Services are just containers you want to run within a multi-container setup, just like I've shown or explained here. So let us look at a very interesting example. I'm going to open the app that I wanted to cover in this video. So that is one that has a lot of things to it. I'll go and open it. I think that's the FastAPI Docker Compose example. So I think we can mark this off because we've covered it. So I'll cover it with X. And then I explained this at the beginning of the video. Now we have looked at the Docker Compose YAML. So we've also looked at services. We've understood that those are basically containers we want to run within our multi-container setup. Now I'll explain this when it comes to what we're going to be talking about and this. So let's look at the application we're going to be Dockerizing or containerizing. So this is a very simple FastAPI app, and those who have been watching will understand that this is the application we built for the video where I was talking about testing with PyTest. So this application is one that has a simple database. It uses quite a lot of things. In fact, let me just walk you through the code and you'll then realize what we need to set up for it to work. So to start, we have a simple app. If I went ahead and deleted these SQLite 3 files, and maybe got rid of some of the other junk that we do not need, like the dot coverage, the HTML curve, and maybe the PyTest cache, I would have this basic setup right here. So inside this is a very simple application. That application is a FastAPI application, and all its code is found inside the source folder. Within the source folder, we basically have two directories: books, which has the code for the API of books, and then DB, which has everything that we need to have when we are dealing with a database. So how we connect into the database, I created a very simple engine. I'm using SQL Alchemy in here. This has an engine. The engine is pointing to a specific database, and that is read from my environment variables. Now, those environment variables are created or read from the env file using Pydantic settings, just like you can see right here. For more about this, you can go ahead and watch the FastAPI Beyond CRUD series. I talked about all these things. But what this application is one that has its code, like the simple Python scripts I've been showing, plus some other external dependencies, like let's say Postgres. In the last example, or in the last video, I showed how we could run Postgres as though it was installed on our machine, and we did that through running the container from the image we downloaded from Dockerhub. So what we're going to do is to now run that same Postgres with a FastAPI app as though these were packaged in one application box or inside one container. So to do that, we are going to first of all build the image for the simple FastAPI app. If I run this app, I'll have to be in my virtual environment. So I'm going to go ahead and activate it with source env scripts and activate because I'm on Windows. And then I'll go ahead and do something like FastAPI dev source. And then I'll point to my host, or let me point to the port since I'm going to, of course, run on localhost. I'll say my port is going to be 8002. So that will start the simple FastAPI app, and everything is working fine. Let us go ahead and go to the docs. So you see then the database is created in this simple SQLite 3 file, but we want to migrate this to Postgres. So yeah, this is a very simple basic CRUD API that's using FastAPI and Postgres. So yeah, let's now see how we can containerize this. So to run this as a simple or single container, of course, we just need to understand the steps that are taken to basically create it as its own container. And I think we did that in the last video. So we create a Dockerfile. And inside this Dockerfile, we are going to go ahead and now create the steps taken to build an image from that application. So start by defining the base image. That's going to be Python. I'm writing Python 3.13 slim. And then we shall move on to creating the workda, which I'm going to call /app. Then we shall basically copy the requirements.txt file inside that specific da. So shall do something like copy requirements.txt to that directory, and then we shall run pip install requirements.txt. Once we have done that, actually we need to add in some options here. So let's say no cache da. The reason that's why I'm moving fast here is because I covered this in the last video, so it would be good if you checked it out. So then we shall point to -r requirements.txt. Once I'm done with that, I'll then go ahead and copy the rest of the code. So shall do something like copy dot to dot, meaning copy everything except those that are inside the Docker ignore. Then lastly, we shall expose some ports. So I'll say expose the port 8000, because I think we're going to even use port 8002, just like we did here. So I'll expose that port here. And then finally, we are going to create the command to run the container. So I'll just copy what I have here, and then I will paste it in here. Then I'll specify the host to be all IP addresses. So in this case, I'll say 0.0.0. So I'll turn this into the way Docker wants it. So I'll say host. Oh, it's supposed to be in quotes. So I will go ahead and put that there. Then I'll go ahead and add that. Add that. And yeah, so that's basically it. So that's the command that we're going to use to run this simple container. And now let's try to run the container. So we'll build the image first. So I'll say docker build -t, and then let me just call this what should I call it? Test API, maybe version 1. And then I'll point to the current folder where the Dockerfile is located. So yeah. Real world use cases for using Docker Compose are many. Number one, creating a dev environment. You could create your dev environment using Docker Compose because it allows you to have all these components as though they were part of your app. So you could consider using that. Another thing I've seen is CI/CD pipelines, testing, things like doing integration tests where components that are external to your application are also important. Maybe a real world use case for using Docker Compose. So I've built the image. I'll then run the container, and then I will set up the rest of the other components. So in the meantime, I'll go to the Docker Postgres. Actually had this here. So let me go to Postgres. And this is going to be Postgres, the official image. So what I'm interested in is understanding what I'm going to supply as environment variables. And yeah, at least they give us an example of how to run that here. So we even have the rest of the other environment variables here. So yeah, so I'm going to go back to my image. This is still installing requirements and it's taking a lot of time. Meanwhile, this is a very humble request, guys. You can click the like button to help this video reach many people. I just request you do that. But this same thing can be one we can do in a Docker Compose. I don't know even why I'm building this image from here. So let me stop it. Now, what I'm going to do is to go ahead and set up our Docker Compose. So I'll create a new file, Docker compose.yaml, and then inside here, I'll still define services. So the services we're going to have in here are going to be our, let's just call it our API or our app. And this can be run from an image, but we now know that we can build that from a Docker file that we have here. So we can point to the context and that context will be dot, meaning the current folder. So that's where it's going to look for the Docker file. And then I'll point to the Docker file as that which exists as the file called Dockerfile. So once that is done, we now have to define any other container we want to run together with the app. Now, one other thing we can basically specify here, we can start defining things such as which network the app is going to run or the container is going to run. And we can call this whatever we want. One thing to note is that if you run 2 containers or more containers within a setup like the one we have with Docker Compose is going to create a default network for them to communicate and understand each other. So whenever we use the name of the container to refer to the container, that name is sort of like a mask for the real IP address of that specific container or the real host or ID of that container. It's a unique identifier to that. But when you're within a network, you can use that network as the host name to access that. I'm going to be showing how to do that with Postgres. So for now, we can just provide a network here. So networks is going to be sort of like a list of the networks in which this application is going to run. Now I'm just going to create a simple app network here, and then I will specify down here that our networks are going to be only the app network. So I'll just come here and say app network. Guys will forgive me, I'm a bit tired. But what happens is we've defined API as our service right here. We've defined how we're going to build that from a Docker file. And we've also defined a network in which it's going to run and communicate with other containers. Now let's go ahead and also add some other networking stuff. Of course, we've exposed this port 8002, but we need it to work with the port of our local machine or be exposed on that exact port, but on the host machine, which is our local machine. So for us to do something like that, we'll then have to point to, let me actually just put it right here. I'll say ports, and this is going to be, we shall point to 8002 of our Docker, pointed to 8002 of our local machine. Now the reason as to why we've done this is because when we run this app, it's going to be running within the Docker network. But if we want to expose it to the outside world or on our computer, then we'll have to run it on this IP address, which basically means that that port is going to be exposed via all IP addresses that will be assignable from Docker. So by accessing that, we shall then be in position to access the container's IP address via 8002 because we forwarded that port by doing this mapping that we have right here. Another important thing we may want is volumes, but I'm going to be setting those up for the Postgres since there is nothing we actually just need to have persisted in our app except for maybe the Docker, the database. I think the database will be the one in which we'll define a volume. But the basic thing is services. So we have one service defined. Now let's define our second service, which is going to be the database service. So the database service is going to be a Postgres service. So this Postgres service is going to be built from an image. So we can do something like image, and then you point to Postgres latest. Now I'm pointing to Postgres latest because that's what I have as the image. So if I go back here, I actually have Postgres latest as my container image for Postgres. So this will not be downloaded. And then I can go ahead and specify PostgreSQL specific things. So in that, I can start with things such as environment variables. So environment is a key that can help you to specify which environment variables you want to define on your container. For this example, I can just refer to the documentation here. So PostgreSQL uses several environment variables which are easy to miss. So the only one that's required is the Postgres password. So that's the exact one we're going to start with. I'll copy it, paste it right here. So these are environment variables. Now for this one case, I'm going to first of all hard code it inside here. But then I also demonstrate how we can put that in our environment variable file. So I'll hard code it here and say Postgres password is going to be test pass, maybe 1, 2, 3. So that's going to be our test pass. And then I will go ahead and put another one. So we have this environment variable is required for your Postgres image. It must not be empty or undefined. It sets the super user password for PostgreSQL. The default super user is defined by the Postgres user, so we need to also provide that. So this is the user we shall use to connect to Postgres. So let me just call that user sample user, or let's just call that test user. And then I will go here, Postgres database. This can be used to define different name for the default database. So I'll just go here and copy this. I will paste that, and then I will go ahead and simply provide the database. So my database in this case is going to be testdb. Now, if you're confused about all this, I'm going to go ahead and re-explain it. So those are the environment variables we need to specify for our next container, which is our database or our DB container or service. Now I'm going to also provide ports similar to what I did for the other one. We want to access Postgres on port 5432 on our local machine. So that means you have to map 5032, which is the default port that's running within the Docker container, onto the one that is running for our local machine or our host machine, which is 5432. Now, one thing is that containers or services can also depend on each other. So Docker Compose allows you to specify how two services may depend on each other, or how many services one has to wait for before it is actually started or before it's actually run. So that is done via depends on. So we can do something like depends dash on, and then we can point out which service that, or which services this specific container depends on. For example, app or API may need the database to start before it actually starts. And therefore, for that reason, we may have to specify that under the list of services it may wait for before it actually runs. Now, another thing is to provide the network in which this is going to run. So since these are going to be running within the same setup, it's necessary we just specify the network to be the same network that we created. It's actually networks. So networks, we shall provide the app network. And then one other thing that we've forgotten is now volumes. So I'm going to now talk about what volumes are. So think of the application or container as one that can run but needs some sort of persistence for data or files or anything that you may not need to change as long as your container is going to run. So you may have a database that's going to have some sort of persistent data, and for you to keep that data persistent, you'll have to then use volumes to define a folder that Docker is always going to look at as one that's not going to change, or one that's not going to be removed or erased. So volumes are Docker's way of specifying such folders on the containers file system. And the way we do that is by coming right inside the volumes list, and then we give the name of the volume, such as the one I'm going to be naming DB data. So DB data is where PostgreSQL is going to persist all its data. And now we're going to point to a location on the containers file system. Now for Postgres, normally the data is stored in a folder on Linux, which is called var/lib/PostgreSQL/data. And when we provide that, we can then be in position to keep that data persistent. So that means even when we run our Docker Compose app for the next time, that data will not be lost. Once you've defined your volumes, you'll now go ahead and create the volumes section, and then you'll provide your volume. So we've only provided the DB data volume, and that's it. We've written a Docker Compose YAML file. So let's go ahead and now deconstruct this. So what I'm going to do is to make this small, make this small, make this small. The first thing to note about a Docker Compose YAML file is that it will contain services. Services are the most important thing in a Docker Compose file, as they define what containers you are going to be using. Now, in this case, we're having an application, which is our API or the FastAPI app, and then we also have our database, which is going to be a PostgreSQL database. Another thing that is important in Docker Compose YAML is going to be the networks. So networks are Docker's way of helping containers talk to each other. If you're going to have the API service or the API container communicating with the DB service, such communication cannot be done if these two are not in the same network. So for them to talk to each other, Docker will have to have some sort of network in which they are all connected and they can be in position to talk to each other. So that's the network we've created as our app network right here. Then volumes. Volumes are simply persistent storages or persistent folders on the containers file system in which data will not be deleted given any state of the container. For our case, we have only Postgres that's going to be persisting the data for our application. I don't know if you guys are still with me. You can leave that in the chat and update me if you're still with me. I would really appreciate that. You can just maybe type a one in the chat or say hi in the chat to let me know that you're still following along. And also feel free to make suggestions or ask questions, and I'll be in position to go ahead and read about those questions or make some research, and those will be inspirations for more live streams or more, let's say, videos about Docker. So yeah, now let me continue. We've talked of the three basic components: services, networks, and volumes. Now let us look inside our services. Inside this service, we've defined a way of, first of all, running or creating an image to run the service. And then we've also defined how to run the service. For our first case, we provided Docker or Docker Compose with how it's going to run our service. So it will have to look into our folder, get a file called Dockerfile, then run the service. Next, we defined how the networking is going to work. So since we've exposed port 8002 in Docker, we need to access that on our local machine or our host machine. So by doing that, we did some sort of like port forwarding. We port forwarded 8002 inside Docker to 8002 of our, so that's going to be the 8002 of our machine, so that when the app runs, we can then run something like localhost 8002 and then access it. Then we specify the network. So networks, we actually have only one network, which is the app network, and that is the network which the app is going to use to communicate with any other external service that's within the same application setup. So let's move on. Depends on basically specifies what other container is needed before this is actually started. So API is going to depend on the database, and therefore depends on, basically specifies that. Then inside the DB container, this is straightforward. We have an image, which is Postgres latest. We have environment variables, which we've defined here. And then we have things like ports. How are we going to map the port of the container in Docker to that of our local machine? So that's what we are doing here. And then network, still, we are pointing to the network we've created for that whole setup. Then volumes, we are going to persist the PostgreSQL data inside this folder, and that is the same volume we are having here. But let's say if we had the volume on our API, would still go ahead and add it to our list of volumes right here and define other things. Now, Docker networking and Docker volumes are two topics that are in the advanced section of Docker. I would advise you to go and read about them more in the documentation, because it's a really good documentation. But also, I will create videos separate to only those topics, because when you talk about networking, we talk about the different types of networks, and then we talk about how they work and all that stuff, which is kind of advanced. So I think of making a different video to cover those two topics. So volumes, same thing. I guess I'll just have to create a separate video to cover the topics, which is more in detail. But think of a scenario in which you have your real world app, and your real world app has all these components. It has your app, it has your database, it has your cache. You even have a task queue, because you have a lot of things that you do not want to run on demand. You want these things to execute at maybe 3 a.m. when everyone is sleeping. Such a setup can be very important, because all those can work in the same environment with the same networking, with the same configs, and they will run flawlessly. And the command that will run them is the simple command of docker compose app. So what will happen here is that in case each of these images does not exist, Docker will first of all fetch them, pull them. After pulling them, it will then run containers out of them. Then it will manage any other complexities like networking, environment variables, and all that stuff. I have a question here. For every container that is added in the Docker Compose, do we have to first create an image for them, or we need to just download from Docker Hub? Actually, it doesn't have to be like that. For the first example, I showed you that you could have an app for which you have Dockerized. You can have a script, just like the two scripts I showed at the beginning of the video. One running code for JavaScript, another one running code for Python. So that script is a simple script that you can run locally. But then we went ahead and wrote its Dockerfile, which is a description of how we are going to create an image from that script. Then we ran a container from that. So we could easily point to the image we've built from that Dockerfile, or we can specify the Dockerfile and then tell Docker Compose to use that Dockerfile to build an image. So this is the build step right here. The build step is one in which Docker will look for a Dockerfile, build an image, then run a container without us having to overthink it. So that's exactly what we did here. But for the purpose of Postgres, we do not have the code for Postgres here, so we cannot build the image ourselves. What we can do is to pull it from Docker Hub and then set it up to run here. So in case I did not have Postgres, Docker will pull it, download it, and then run it. It will just have to use the things I've set up right here. Then another question is, after adding these services to the Docker compose.yaml, do you need to also build the images for it? No, that is what Docker will do. You do not need to set things up. You will have to just run Docker Compose. In fact, let me just go ahead and run Docker Compose app. So I have some errors here. Additional property depends on is not allowed. I think I've made a mistake. I think that's depends on. Is it depends underscore on? I think that's what it is. So always make sure to read through what this does and maybe look at the documentation for what may go wrong. So you see what's happening here? It will do DB pooling, but since DB is already available, or Postgres is already available, it won't have to pull it, but rather just use that or run the container from that. And now you note that since we specified the image to be built from the Docker file, it will go ahead and follow all the steps that we wrote inside that Docker file. So that's why you see it's running pip install requirements.txt. So it's going to go ahead and read this, follow each of the steps that we've defined here, and then basically move on to run the container. But it will first build the image. So the steps are: have your code, write a Docker file of how you want to build an image from that Docker file. So the image is going to be sort of like a prototype, I mean, not a prototype, but a blueprint for how the container is going to run. Excuse me for 1 minute. Okay, so yeah, I think I should get a glass of water. But feel free to leave me a question, a comment, a concern. I'd really appreciate. I'm really appreciative that I really I really appreciate the fact that you guys have hung in there and you are still watching even up to this time. We are getting into almost 2 hours. So things to note, this is actually a superset of JSON. Thanks for the comment, Aldrich. I've read that the comment by Aldrich, which said that this is a superset of JSON, which means that we can have the same stuff inside a JSON file, and then we can point to that JSON file, and then Docker Compose will be in position to still build a multi-container setup as though we had it in YAML. So yeah, I hope this is almost completing. Let me go and grab a glass of water real quick. All right, so yeah, I'm back. I hope you guys are. I think you guys are okay. I think you guys are. Yeah, let's resume. Let's resume. Let's resume. Let's finish this up. So, what we've currently done is to let me drink something here. Um. So what we've so far done is to run this with the setup we've done, and we can see what Docker did here. So with a single command, docker compose app, what we did was to go ahead and build an image of our code, and then we also ran the container, just like you see right here. So if I go to the logs, I have those of FastAPI, which are here, and I also have those of the container right here. But for a more visual, more understandable way, let me show that in Docker Desktop. So Docker Desktop has this interesting way in which it can basically go ahead and show you a Docker Compose setup. So I'm going to delete this. Let me just delete what I have here. And then after deleting that, I'm now going to go to the only Docker Compose setup we have. So when you get to think of the app we containerized, we had two services we defined. The first one was the API service, which we built from our Dockerfile. The second one was Postgres, which we called from an image that we do not have to build. So if we went ahead and inspected those, we see the logs. These are the logs of the first API application we ran. Now, since this is using an SQLite database, we now see that it's now going ahead and doing all these things. So yeah, it's creating the database, and we can inspect, therefore we can see all the other things that are running, or basically we can see all there is to this container as far as attributes. Then I'll try to maybe exec. So this is the same thing as running docker exec it inside the container. But in this case, I'll run a bash terminal. And when I run this bash terminal, I can ls. So this is all the files that we specified for our container, or the ones that we built with our image. So what happens actually is that when building an image, all files that are required, or all the source code that you're going to run the container from, is going to be moved inside the image. So all these are inside the image, and now we can see them within our container file system, just like you see right here. So Docker is a really cool technology. I honestly want to be using it, and I can't wait to learn it in much more detail. Then we can look at things such as files, where we have the files for our app, the same files that we have in our VS Code are the ones that are here. Another thing we can do is to see the stats. So the stats are how those are using our resources. So that's just basically what I wanted to show you. We see that this is one setup, first API Docker Compose demo. I think that's what they are calling it here. But that setup is having two containers which are running as API1 and DB1. So that's the setup that we have right here. We can even see things such as what commands are being used, just like you see right here, and then what images are being used to run those containers. Now, away from that, let's now see the power of Docker Compose. So Docker Compose app is the only command we've been using, and that's been helpful in a way that it's helped us to create the containers and run them. What if you wanted to destroy the containers and stop them? That would be the opposite. So Docker Compose down will do the opposite of that, to go ahead and remove the created containers, and it will go ahead and delete them. So if we did something like docker compose down, that will go ahead and stop the containers that we created. So it will stop them and also delete them. So that's exactly what we have. It will also go ahead and delete the network in which these containers are running. So for your information, when you go back here, of course, you'll see that our container has stopped. It's exited. So this is the DB service. It's exited with code 0. Code 0 is always used to show that no error occurred. So if you see something like a code that is greater than 0, then you know that there was an error that led to the stopping of the container. But since they have exited with code 0, we can say for sure that they exited because we stopped them. So that's basically how that works. So in case we run this, they will be run the same way. And then we'll see the logs. So the database will start first since it's what the application depends on. Then the API will follow. Now, one other thing to note is that throughout all this, since we defined a volume, that volume is not going to be deleted. So in case you want to delete that volume, you'll then have to use docker compose down, but with a specific option. You can do something like docker compose down and then dash volumes to delete the volume. So if you have the data in the Postgres, that data will also be deleted. And then you'll have both the containers and all the volumes gone. So as much as you may delete the containers, still the volumes will be still available. So that's how you get rid of the persisted data in the PostgreSQL in case you need to do that. So let's look at some other commands. You can do things such as docker compose logs. So that will show you the logs of the containers that are running. But since we do not have any of those, we have stopped them, then we'll see nothing. So let me go ahead and try to run docker compose app again. So you see, this time when we are running docker compose app, the volume has to be created. So because it doesn't exist, of course. Let me read through some comments here. I have 10K on my MTN line, please. I don't know what you mean by that. You want to give me a small kind donation or? But if you can, I can leave my number in the chat and I see where that goes. I also need the money. Thanks guys for watching. So because we deleted the volume, you can even see Postgres kind of creating that directory once again and copying all the stuff, all the Postgres specific stuff to that folder or that directory once again. Yeah, now our two containers are running. So we were trying to show logs on all of them. If I say docker compose logs, we can now see the logs on both of the containers. However, we can also go ahead and show logs for one specific container. So we can do something like docker compose ps to show the running containers. That will show us app, and that will also show us it will show us app, but it will also show us the, let's say it will show us app, but it will also show us db. So let me share my number here in the chat. Let me go to the live stream here. Okay, so yeah, so that's my number there. You can even chat with me on WhatsApp if you're interested. Yeah, but yeah, thanks for the kind donation. So now let's move on to what we want to talk about. So Docker Compose PS can be used, Docker PS can be used in the same way. You can just say Docker Compose PS and see the running containers. You can also do compose. So in this case, the interesting thing is that we have names for all the containers we've so far created. So if we wanted to see the logs of one container, we could say Docker logs or Docker compose logs, and then the name of the container. So in this case, we can do something like Docker compose logs API, and that will only show the logs of our API or our FastAPI application. And then secondly, we will do the same thing. If we wanted to see the logs of DB, then we'll see Docker compose logs and then DB. So yeah, that is the thing. So once we've been able to look at that, we can also run things like terminals inside these containers. And that is very, very useful when we want to do things such as running migrations or running tests inside those containers, or basically running any command that would need us to interact with the code. So in that case, you can do something like Docker compose exec -it. So what this does is to basically help you to execute a command, but then it has various options. I means interactive. You want to run some sort of like interactive session inside the container. And then T is for TTY, which is basically a pseudo terminal or a virtual terminal. So you want to run an interactive terminal inside that container. Let's begin with the app container. So I can say app and then bash. So what this does is to run the container app, but then we want to execute the command bash inside that container. So if we did that, service is not running. So I think I have to, oh, I don't have a service called app. Sorry. I have a service called API. So that will then go ahead and open up this terminal here. So if we say ls, that's the files we have there. If we run pytest, I actually have some tests in there. You'll see that those tests will execute because they are inside our container. Now, this can fail or this can succeed. We actually have tests running. So it's only one test that's failing for that simple application. So these tests are now running within the container. Another thing we can do is to go ahead, exit out of here, and maybe run our DB service. So in case you wanted to like access the Postgres, what you need to do is to go ahead and still do the same thing, Docker compose exec. In this case, you'll do -it. Then you want to run your command, but first let's provide the name of the database container or DB. Then you provide the command. So we want to run PSQL, which is the PostgreSQL shell. And then we want to provide option like the user being the user we defined. Actually, that's uppercase U. So that's going to be the user we define inside our environment variables here, which is our test user. And then we will use that. So we can do test user. Let me actually go back here, and then the test database will be test DB. So we can do test user, and then the database can be the test DB. And that way we can access this database. So if we did things like that, we don't have any relations with this databases. We now see that our test DB, the one that we specified to be the default database, is available. So that means we can now use the database instead of the SQLite 3 that's currently using the app. But let's first of all access this app on our machine. So I'll click this and then it will open up here. So I think I'll need to go to localhost 8002/docs. and there we shall be. So you can access the app on localhost. Now, we need somewhere in which we are going to use the app or access the app, but on our thanks so much. Thanks Code Accent for the kind donation you've sent me via mobile money. I really appreciate. So yeah, now let's go ahead and try to look at how we can connect to our database. Now, this is how Docker networks work, right? Um, let's say we have, how can I even explain it? Let's say we have our simple container setup. Let me just use comments here. So let's say we are having our box like the one we have here. And inside that box is going to be basically our app or our API, and then we shall also have, so we shall have our API, and we shall have our app, or we shall have our DB. So DB is the DB container, app is going to be the DB is going to be the DB container, API is going to be the app container or the FastAPI app container. The container or the containers will run inside this box. There is no way they will get out of this box. And let me make it even larger so that you guys can see. The network in which these are going to communicate is one that Docker is going to create and manage. So that means that for them to talk to each other, we have to use the same names we are using inside here. So let's say we were constructing the PostgreSQL URL to that database that we're using inside Docker. How would we do that? So to do that, we'll have to do something like PostgreSQL, and then so that's the scheme. Then we'll have to provide the user. Of course, that user is going to be test user. And then we'll have to provide the password, which is, let's say, test pass. And then we'll have to provide the host. So instead of saying localhost, we have to name the name of the host, which is the name of the service we provided inside our Docker Compose YAML. So that's exactly what we need to refer to. In that case, we have to say @db, and then we do not even have to provide a port for it. Since they're in the same network, and we've specified that they will be using the ports we've defined here, so those are the ports we'll be using, we then just have to point to the database, which we call testdb. So I think that is how, this is basically how you're always going to connect to Postgres. If you've defined your host as db, then that will be the name you'll be pointing to. So instead of pointing to a particular IP address or pointing to the database on a specific port, this is going to be the name of that service that you're going to be using. So yeah, let's continue. Now we have a job of modifying this app to make use of environment variables that work with our PostgreSQL database. So to do that, I'm going to come right here. I'm going to delete app db.sqlite3. I'll go to my .env. I'll change this to use PostgreSQL. Now, one thing you can note is that this uses SQLite plus IO SQLite. This is the async driver for SQLite. So by default, Python has the PySQLite, but then that can't work if you're using an async DB API. So you have to install something like IO SQLite. But for Postgres, we have to use something called async PG. So we're going to have async PG installed, and then we shall construct our URL in this way. We shall say PostgreSQL plus the driver, which is async PG, then the rest of the stuff. So let's go ahead and do that. So I'm going to modify these variables right here. I'll just come right here and say that we'll have this PostgreSQL plus async PG, and then we shall provide all of the stuff that we've defined inside our Docker Compose YAML. So I'll pull it here. Maybe I'll go ahead and, oh, I'll even leave it. So what I'm going to do is to just split this into two, close this, have this. So what I'm going to do is to say PostgreSQL plus async pg, and then I'll point to the name of the user, which is test user, and then I'll point to the password, which is test pass 123, and then I will go ahead and point to the host. So in this case, instead of pointing to the database of localhost 5432, what we shall be pointing at is DB, since we are operating these containers inside the same network. So DB will be the name that this app or API will understand, since it will be inside the same Docker network. I'll make a video explaining all this in detail, I promise. Then testDB is going to be the final thing we shall have to provide here. So that's going to be the name of the database. One important thing to note is that we can even remove this from the Docker Compose YAML. So to do that, I can just go ahead and put this in our .env. So I can just come right here, provide PostgreSQL password. I can name this test pass 123, and then I can do the same thing for the Postgres user. So Postgres user is going to be test user. And then I will go ahead and do the same thing for Postgres DB. So Postgres DB is going to be equal to test DB. So once I've done that, now that means I should be in position to edit this file so that I do not have any hard-coded environment variables. So how can I do that? There is syntax that Docker Compose uses, one that can help you to basically read a variable from an environment variable, or get a value from an environment variable. So that's basically how you write it. You go ahead and say, so this will be Postgres underscore user, and then this will be Postgres underscore DB, and that will be it. So this will be read from the .env that we have here. So to see this in action, let me go ahead and run the containers once again. So I'll stop them. When you press Ctrl C, the containers will stop, and then you'll be in position to go ahead and run them again. So if we did Docker Compose app, you see that they'll be created and then they'll run, and yeah, so we are good to go. Now if you've successfully connected to our Postgres, this time we realize that the database tables will be created, but they'll be created inside the Postgres database instead of the SQLite 3 database. So I guess that's what we need, but we don't see anything happening. So we may have to look at them. So application startup complete. I don't know what exactly happened. Do I have anything in my code that went wrong for the database tables to not be created? Let us just do some confirmation. If I went here, I can do Docker Compose, and for my case, Docker Compose, this will be Docker Compose exec -it, and then I will have to execute the app, execute bash inside the app for the API container. We don't have an app container running, so that's API. And then maybe I'll ls. So I still have app.db.sqlite3. Let me go ahead and remove it. So if I say rmrf that, one thing to note is that I need to have my env file pushed, so I do not add it to the Docker ignore. So this is going to be app.db.sqlite3, and when I ls, I actually have test.sqlite3. So let me also go ahead and get rid of that. So say test.sqlite3. So if I ls a, I have this file has to make it in here, because since we are not hard coding every environment variable, this file has to be pushed to the containers file system without being ignored. So let me exit and try to delete volumes, or try to do something of that sort. So docker compose down, and the network also is removed. So let's do docker compose app. Okay, so docker desktop. Okay, so there's a question here. Does Docker Desktop use our local storage for every app installed and run, or cloud? It uses your local disk. In fact, you'll be shocked to find out you'll be shocked to find out how much of your storage Docker will use. It uses a lot. And I'm going to be showing you a command you can use to delete dangling images, dangling containers, and all of that stuff. So it helps you to like reduce or get some more space reclaimed. So yeah, it uses your local storage a lot. So our database tables are being created. Now I'm not really sure if this is running. Oh, I have this also running. So let me go ahead and stop that. And then we'll try to execute a terminal inside there. So let me try to see. If I say docker compose exec -it to run a terminal inside my app container. I don't know why I'm calling it app. It's supposed to be API. So I need to confirm. Still, I'm using app.db.sqlite3. Maybe the .m file, or maybe I need to rebuild the entire images. So there's also that problem. Sometimes you just need to rebuild the entire images. So let me just actually do that. I'm going to docker compose down to stop the running containers and delete them. And then I'll rebuild everything with docker compose build. So that is the command you use. So I'll do docker compose build, and that is going to go ahead and rebuild everything. So it will walk through the Docker file of the app we specified, and then it will install everything as though it didn't do that. And how many of you guys are still watching? If you're still watching, kindly leave me something in the chat. I'd like to know how you're doing while this is also building. Hello. Are you guys still there? We are 2 hours in. Okay, so we've built our images. So let's go ahead and have a look at them. Now I'm going to come right in here and try to run everything again with Docker Compose app. And yeah, so our first API is now going to run. Oh, we've got an error. There is import error, 3 validation errors for settings. So Postgres password, extra imports are not permitted. So yeah, this thing Pydantic settings is interesting. It validates your .env, and if you have extra things, you have to provide a way for it to add those to your settings. So since you provided the extra PostgreSQL stuff, it is failing to read them, or it's giving us an error. And that's one thing that's interesting. So our service, the one that we have as our API service, is not running simply because of that minor issue. So yeah, we now need to make this run. So let me see how we can add extra inputs, Pydantic settings. Okay, so model config dictionary. So extra ignore values equals none. So we have ignore, we have forbid, and we have allow. So what I can do is to go inside extra ignore. Let me go to that. So this is becoming a FastAPI tutorial. So I'll go to config.py, and inside config.py, and I have to go ahead and specify extra. So let me see how this is going to work. Extra, I don't know, is this where we put that? I'm confused. Config dict, model title generator, field generator, string upper, blah blah blah, extra. So let me try to see the class definition of this. I'm not pointing to the virtual environment. Thank you, VS Code. Do you guys think VS Code is the best text editor? I feel like it's not the best. It's just that Microsoft has has a monopoly over programming, and the best way to do things is found in VS Code, but I don't think it is the best. I've been trying out the Z editor, but the problem with the Z editor is that it doesn't have all the cool features you can find in VS Code. Are you guys using AI to code? If you are, you can also tell me how that is going. I'm using AI to code, but then I feel bad about myself. I feel like I am cheating in some way. So let me try to see here. We need to find and to provide extra, but I do not know how to do that. So it's inside, it's a subclass of config dict. So yeah, extra values. So I think I need to provide it here as extra equals allow. And then I will go ahead and stop this, Control C, stop the containers, and then we'll build and then run the containers again. Oh, thanks for watching. If you're still there. Pydantic settings was installed. It's just that this VS Code thing did not recognize the virtual environment. So I had to point here, I select the virtual environment, and then it was finally accepting that it's installed there. So that was the problem. Me, I'm learning to use wrap. Can you explain what that means? I don't get you. What is wrap? Okay, so we built a setup. Let's run Docker Compose app. Nice, our app is running. So now let's confirm if our database tables are being created. Yeah, they are. I'm saying PG catalog. This is for Postgres. Interesting. So now let's go ahead and let's dig in. So I love my Postgres. So what I'm going to do is to let me now run Docker compose exec -it, and in this case I want to run PostgreSQL. So I want to execute the DB, but the command is going to be psql user test user, and then the the database is going to be our test DB. So in case we created our databases successfully, we now have our books table, just like you see it right there, which is interesting. So we can even see its definition. We can describe it with using /d and then books. So it will show us the tables. So we are now operating with Docker Compose. The app is running with Docker Postgres, which is interesting. So let me go through some of the comments. I'm having Code Accent saying it's a new tool for developers. Okay, that's interesting. I use AI to learn. I use it to help simplify certain concepts, understand errors better, learn frameworks, etc. I've used it to code and ended up going down a rabbit hole. The best IDE I've used has to be JetBrains. VS Code isn't bad. I feel it gets the job done. Extensions are a key though. Hope Docker has MySQL image. Of course, it does have MySQL image. In fact, if you search for MySQL, I think I have an image here. You can pull the MySQL image. I think I deleted it, but then the official, actually, most of the software that you want to use is available on Docker Hub. So you'll just have to search for it. So if you want to use Postgres, you can go to official images here, and then you see things like memcached, things like, let me go to databases and storage. So you see Redis, memcached, MySQL. you can use MySQL in your project. You just pull the image and then use Docker Compose to point to it like the way we've done for PostgreSQL. So you can do the same thing. If you're using MongoDB, you can still use the official MongoDB image. MariaDB, yeah, pretty much any database you know of, Neo4j, Cassandra, Apache Cassandra, and so on and so on and so forth. Even PHP by the way, can be run as a Docker container. Now, that is actually something interesting. If you can run PHP with MySQL, you can run MySQL in a separate container and then run PHP as a separate container. And all that can be done via Docker Compose. So there you have it. So as far as IDEs are concerned, I honestly do not like IDEs. I'm a text editor kind of guy. So when you talk of JetBrains, yes, I get it. It is a very, it's like what should I call it? It's like the jungle of text editors, or it's not even a text editor, it's an integrated development environment, so it has everything. That's why I sort of like called it the jungle of development tools, so it has everything. But when you see VS Code, what makes it powerful are the extensions. And I wish all those extensions were what Z had, because Z is best of Rust and it honestly does the job really well. So now our container is running and our multi-container setup with Postgres and FastAPI is running. So you can pretty much run this app as though you have the app in production. In fact, you can even deploy this in production for as long as you are going to always access this app from one host. So if you're deploying your simple app like the one we have here, a very simple service, it can be deployed as a standalone service using Docker Compose. I think I'll make a video about that in the future. But yeah, honestly, I'm looking for some other things I can talk about before I end the live stream. It has been a long one, and we've looked at a lot of things. And I want to appreciate you guys for watching, for staying around for all this time. I do not do this because I know a lot. I do this because by doing so, I get to make this concept stick more. So I really appreciate it when you guys tune in and watch things with me. So let's conclude the video. Today we've basically looked at Docker Compose, a tool that allows us to run multiple container setups. And it does that by using a file we call the Docker Compose YAML file. We've explored some of the reasons as to why we may want to use Docker Compose, which pointed to things like simplicity, in that you use one file to write everything you would have done by running all the commands for running multiple containers. And then we talked of consistency, in that an app you run with Docker Compose. So if I give you, or if I put this on GitHub, in fact, I'm going to deploy or push this to GitHub. If I give this to you, or if you cloned it on GitHub and you had Docker and still ran it with Docker Compose, you'll have the same setup and the same tables in the database will be created the same way, and therefore the app will run the same way. So that's what the consistency is. For portability, that is the whole thing of being able to carry this app from my machine right here to you by just sharing the docker compose.yaml and all the rest of the source code. Now, another thing is basically the scalability. For the scalability, I talked about how it is easy to manage resources and maybe add instances of a service to basically any service you may define inside your docker compose.yaml. Then we talked about the key concepts. We have created the Docker Compose YAML for the simplest example, which involved running a Python script and a JavaScript script. And then we talked about things like services, which are the containers you run within your multiple container setup. We talked of networks, so we didn't discuss them in detail, but they are simply Docker's way of allowing communication in between containers. And then we talked about volumes, which are persistent storages that we set up on a containers file system. Then I showed some examples, and we've successfully ran a FastAPI and a PostgreSQL database. So I hope you guys have learned from this video. It hasn't been the most advanced. In fact, there are a lot of things you can do with Docker Compose, but you can fill your curiosity by going to the documentation. You can go to the documentation here on docker.com, and then you can read about Docker Compose, how it works, how you can use it. You can go to the how to section. You can basically read through all these things, and then you'll feed your curiosity. You'll know so much more about Docker. What I'm going to be doing is to make more of these live streams. I'll be picking a topic every week and then coming on here and explaining it our way. And I hope you guys have found value out of what we have done today. So let me read the comments and then we shall end the live stream. I'm searching how I can create like 10 bots and add them to containers with Docker. Is this something we can achieve? Yes, you can. You can. And if you can containerize one, then you can create multiple instances of them. You can then make a video of how to do this. Yeah, I can make a video about how to do it, but then you can also go to the documentation and try to read about it. I think by doing that, you'll learn quite more than just watching my tutorial. Then lastly, thank you very much. Very powerful introductory video. I really appreciate everyone who has been around. I want to appreciate Jamil, Aldrich, Team Droid, Kodaksen, who has been around up to this point. You guys are amazing. And yeah, also Cabello Sekele. Thank you for watching. I'm really glad that you guys tuned in, and yeah, have a good night, have a good day wherever you are. I'm going to bed. See you in the next one. Bye.